Anyway, so inverse of a function. So we have a bit of this concept in math as well. So when are you going to do live streams of solving full papers for maths? देखो full papers मैं नहीं solve करता streams में, especially after my channel got a strike when I solved a couple of papers. I will do them, but I may not do the recent ones. But there will be a past paper session starting very soon. Yeah, we're just starting. So you guys will find out when a past paper session starts. Okay. Math की मैं most likely topical past papers इस तरह की streams करूँगा, और I'll do some non-calculator practice, those kind of streams. But I'm gonna have to see. Maybe I'll test it out, see what it's like if I do a stream of a yearly past paper, and then see. Anyway, so today is the 3rd Feb 2025. So we're doing inverse of a function. So it's a 3-step process finding the inverse. Sometimes it requires a couple more, sometimes it requires one additional step. So we're going to talk about that. So we're going to do this with the help of an example. So let's say that you have f of x, which is equal to 3x minus 1, and our task is to find f inverse of x. Now, it's important theoretically to understand the whole idea of inverse. Inverse does the opposite. Okay, it's like, see, we go to a shop and we pay some money, and then we buy something. Let's say you go to a shop and you want to buy a bag of chips. You're going to pay some money, you're going to get a bag of chips. The inverse of this would be the opposite, that you go to a shop, you give the bag of chips, and you get the money in return. So what happens is that in an inverse function, your input becomes the output, your output becomes the input. Okay, so for example, before we learn how to find out f inverse of x, let's plug in a few random values in f of x, and then let's see what we get as a result. Okay, so just some random values, no specific pattern. So let's say I plug in 1, let's say I plug in 2, and let's say I plug in 3. So these are the x values, also known as the domain or the input. And now we're going to find out the corresponding y values, also known as the range. So if I plug in 1, 3 into 1 is 3, 3 minus 1 is 2. So the image or the output of 1 is 2. If I plug in 2, we get 5. If I plug in 3, we get 8. So this is the output. Okay. Now, here's what we're going to do. Let's learn the step-by-step procedure there is to find inverse. So step one is, now you don't have to follow this step-by-step procedure as in to the letter, but understand it step by step, and then you can skip a few steps if you have to, but only do that once you reach a point where you think you will get the right answer if you skip a few steps. So step 1 is replace f of x with y. That's the first step. So that means it's now y is equals to 3x minus 1. Step 2, perhaps the most important step of the 3, is that you make x the subject. Okay, what do? We make x the subject. So let's see if we can make x the subject. So if I make x the subject, what do we have? So after the end of step 2, this is where we were. So y plus 1 equals to 3x. Let's write this nicely. 3x is equals to y plus 1. X is equals to y plus 1 upon 3. Okay, so that's step 2. Then comes step 3. So what's step 3? Step 3 is just a formality, really. So step 3 is that you replace x with f inverse of x and y with x. Okay, so you replace x with f inverse of x and y with x. So let's do that step as well. So this now becomes f inverse of x, which is equal to x plus 1 upon 3. Okay, I'm not aware of that, but this is usually the most preferred method. Okay, so that you replace x with f inverse of x and y with x. Okay, great. Now, the interesting thing that I want you guys to observe is the following. Is this. Now, what I'm going to do is, and we're going to make a general rule out of this. वो ये वो क्या है वो भी आपको बताता हूँ. So now I'm going to plug in the output values. Okay, I'm going to plug in 258. So I'm going to plug in 258 in place of x. So let's plug in 2, let's plug in 5, let's plug in 8. And then notice what happens. Notice what f inverse of x is equal to. So if you plug in 2, 2 plus 1 is 3, 3 upon 3 is 1. So the output of 2 is 1. If you plug in 5, 5 plus 1 is 6, 6 upon 2 is 6 upon 3 is 2. If you plug in 8, 8 plus 1 is 9, 9 upon 3 is 3. So देखा आपने कुछ observe किया आपने? This was the domain of the inverse function, and this is the range of the inverse function. Make an observation. I'll zoom out so you guys enough information to do that. What if you do step 3 first? Yeah, you can do that. You can do that. Ultimately, you have to make x the subject, and once you've made it the subject, you have to show that that's the inverse function. So you can do that. Yes, domain and range have changed. So what was the domain of f of x has now become the range of f inverse of x. We're going to write that down, don't worry. And what was the range of f of x has now become the domain of f inverse of x. Okay, so let's write that down, that the domain of f of x becomes the range of f inverse of x. Okay. And the range of f of x becomes the domain of f inverse of x. Okay, so if you think about it, this is what's happening. That if, let's say, here's f of x, okay, so that's x, y, and then as soon as you take the inverse, what happens? It becomes y comma x. What exactly is this? What kind of a transformation is this? Can I write down some real life context examples for concept? I haven't thought of any, but let me see if I can come up with a few along the way. Okay. So reflection, okay, elaborate. It is reflection, agreed. But can you elaborate a little? When we say reflection, yeah, that's correct. When we say reflection, we have to write, just like when we say rotation, we have to specify, what is the angle, what is the direction, what's the center. So just like that, when we say reflection, it is, we have to specify what line it is. So basically, long story short, the graphical relationship between the two is as follows. Okay, so this is the graphical relationship that f inverse of x is a reflection, okay, is a reflection of f of x along the line y equals to x. Okay, so we're gonna see this in action as well. We're gonna draw it and we're gonna find out. But right now, this is what I want you guys to remember. Another important note that I want you guys to remember is this: inverse of a function will only exist. Can anyone complete the sentence? If it's a one-to-one function. That's correct. So inverse, ये नहीं कि आपका जिस function का दिल चाहा आपने inverse निकाल लिया, नहीं. Inverse of a function will only exist if it's a one-to-one function. Okay. Can anyone think about it, and can anyone explain to me why that is? Why do you think inverse will only exist if it's a one-to-one function? Why not of a many-to-one function? सोचने वाली बात है. Passes the horizontal line test. ठीक है, I agree. But why is that? Think about it. It's not that difficult to actually figure it out. So what happens if you take an inverse of a one-to-one function? After you take an inverse, what kind of a function will it be? It will still be a one-to-one function. Correct? If, let's say, you take an inverse of a one-to-one function, So even after you take the inverse, it will still be a one-to-one function. Okay, so let me see if I have enough room over here. Yeah, I think I do. So here's f of x, and here is f inverse of x. So if let's say it's a one-to-one function and we take the inverse, so that means it will still remain a one-to-one function. For every one output, you will have one. So earlier, at this stage, there was one input, one output. If you do the opposite, same thing, one input, one output. But if it is a many-to-one function, okay, which means that there are many inputs that give us the same output, so it's still a function. But if you flip it, then what happens? Then it becomes a one-to-many relation, which is not a function. Okay, so that's the reason. Yes, that's correct. Many-to-one becomes one-to-many, and that's the reason why it doesn't have an inverse anymore. Okay, so I hope things are clear as regarding how inverse of a function is found. Now, a very common question is that what is the range? Although we've done this, we've written it above as well, but back then we weren't aware of the idea of inverse, so we're gonna write it again. So let's say you have a quadratic curve which has a turning point at x equals to 2. Okay, everything else for now is irrelevant. So we know that the inverse of this function will not exist. Okay, that's not exactly news for us. We know, okay, iska inverse exist nahi karega. Why? Because although it's a function, but it's not a one-to-one function. Okay, it's a function, but it's not a one-to-one function. It's a many-to-one function. But we can always alter the domain and make sure that the inverse exists. What can we do? We can always alter the domain and we can make sure that the inverse exists. So what I can do is I can alter the domain in such a way that I change the domain to x is greater than or equal to 2. Then what happens? In that case, the only part of the curve that we are looking at is the one after the turning point, not before the turning point. So if I erase this, then what happens? This is the only part of the curve that we are looking at, which means the inverse now exists. Okay, so now we can say that inverse exists. Similarly, what I can also do is I can change this curve and alter the domain in such a way that I change it to x is lesser than or equal to 2. तब भी क्या होगा? तब भी inverse exist करेगा. So if I change the domain to x is lesser than or equal to 2, we won't have this part of the curve anymore, but that's fine. It's a one-to-one function, which means inverse now exists. So if I change it to x is lesser than or equal to 2, now all of a sudden, inverse exists. Okay, why? Because this has now become a one-to-one function. Okay, any questions? If yes, feel free to ask. Okay, great. Now this is basically the graphical relationship between these two functions. Okay, I'm going to paste it over here so that you guys have a note of it. So what you see in red is basically f of x, and what you see in blue is basically f inverse of x. So you can see that the two are reflections of one another along the line y equals to x. Okay, so you can see that the two are reflections of one another along the line y equals to x. इसको मैं यहाँ पे भी लिख देता हूँ. Yeah, I'll zoom out here, take a look, and let me know when you're done so we can do some examples as well. Okay. So we found inverse of a linear function. Okay. Now let's see how to find out inverse of a quadratic function. So every many-to-one function can turn into a, yeah, that's correct. Every many-to-one function can be turned into a one-to-one function by altering the domain. So why is that inverse of many to They're not, because it's not a function to begin with. Many to many is not a function to begin with. Okay. Yes, Subhan has answered it correctly. It's not a function to begin with. That's why it doesn't have an inverse. Okay, so we have ourselves a quadratic function. Now, if let's say we apply the step-by-step procedure that we learned above, that you make y the subject, why is there not an inverse? Because then it becomes one to many. So I explained that, Emma. Then it becomes one to many, and one to many is not a function, it's a relation. Okay, so after the inverse, it should still be a function. But if you take the inverse of a many to one function, then it becomes a one to many relation. Therefore, it's not a function. Okay. Now, you can find the inverse as in you, it's not like if you do it, it'll explode or something. You will still be able to come up with an answer. You'll get an answer, you'll get an equation, but it won't be a function. Okay. All right. So if we apply the step-by-step procedure that we learned above here, then you'll notice it's not going to work. Why will it not work? Because if let's say I do step one, which is y is equals to x squared minus 6x plus 5, can I make x the subject? Yes or no? No, we can't make x the subject. So try it out. You'll realize that you won't be able to make x the subject. So an important note. I've lost track how many notes we've written in this chapter, but I hope you guys are. You guys aren't taking the notes lightly. So in order to find the inverse of a quadratic function, we need to first bring it in completed square form. Okay? Yes, that's correct. In order to find the inverse of a quadratic function, we need to first bring it in completed square form. Now, the method that I would prefer to use over here is the one that we learned in math. So I don't know if you guys are aware of it, but I'll share a video. You guys can learn the method very easily. It's not that complicated. So I will, however, try and do one example in as much detail as possible. So what you do is you write x squared minus 6x. So you write the term with x squared and then x, and then you leave a bit of space before you write the constant. Okay. Now you're going to add something over here. You're going to add the square of something over here. And whatever it is that you add, coefficient of x, that'll be 3. So we add 3 square and we subtract 3 square. Then what happens is this part of the expression, okay, this part of the expression is the
Sir, your voice is glitching.
okay. Can you guys hear me now? All right. Sorry about that. So I'll just go over it one more time. So basically, here is what you do. You write down the first two terms as is, y equals x squared minus 6x. You leave a bit of space and then you write the constant. Can we also not make x a subject using quadratic formula and putting values in it? If you use the quadratic formula, then you will have the value of x. Quadratic formula will be used to solve the quadratic equation, not for rewriting it. Okay, so here's what we're going to do. We're going to add the square of something and we're going to subtract the square of the same thing. So what we will add and subtract depends on the coefficient of x. The coefficient of x is 6, half of which will be 3. So we add 3 square and we subtract 3 square. Okay, so you basically add and subtract half of the coefficient of x, given that the coefficient of x squared is 1. If it's not 1, then you take one. You take common. We're going to do an example. Hopefully, we'll come across an example of that also. Okay, so this part of the expression is the expanded version of x minus 3, the whole thing squared. This becomes 5 minus 9, and what's that equal to? that's equal to minus 4. So that means the completed square version of x squared minus 6x plus 5 is x minus 3, the whole thing squared plus 5. Okay, now that you can see that x is compressed, it's in one place. So now if I ask you to make x the subject of this equation, it'll be much easier compared to this. In fact, in this, it's not even possible. Easy, difficult to dur ki baat hai. Here, it's not even possible. Here, it is possible to make x the subject. Okay, so let's do that. Let's make x the subject step by step. So we have y plus 4, which is equal to x minus 3, the whole thing square. Then what we do is, in order to get rid of the square, we take the square root on both sides. So once we take the square root on the left-hand side and the right-hand side, now this is where something interesting happens. Whenever you take the square root on both sides, what happens? Question for you guys. Whenever we take the square root on both sides, there's something plus minus. That's correct. So here, although it's going to be x minus 3 on one side, yes, the square cancels, the square and the square root cancel, but now we have a plus minus y plus 4. Okay, what do we have? We have a plus minus y plus 4, which means if I make x the subject, we have plus minus square root of y plus 4 plus 3. Okay, and then if we do the final step, so f inverse of x now becomes 3. I'm just going to change the order slightly. So it becomes 3 plus minus square root of x plus 4. Okay, so I've changed the order slightly. You can write it as plus minus x plus 4, 3. That's fine. But this is what we end up with. Now, the question is, with plus and minus, what do you think the kind of function this is? What do you think the kind of relation this is? If, let's say, I let plus minus be as it is, that means if I plug in one value of x, I'm getting two different outputs. If I plug in one value of x, I will get two different outputs, which shouldn't be the case. Technically, I should get just one output. Okay, plus minus ka matlab hai, let's say if I plug in 5, think about it. If I plug in 5, so 5 plus 4 is 9. Once we'll have to take the positive square root of 9, and then we'll have to take the negative square root of 9. Then it becomes a one-to-many relation, which means it's not possible. So we have to decide whether we're going to go with plus or minus. Okay, so we have to decide whether we're going to go with plus or minus. So another important note, before we decide what sign to go with, notice that there are two parts to the question, okay? But before that, I want you guys to write this note, that after finding inverse of a quadratic function, okay, after finding inverse of a quadratic function, we either write plus or minus, but not both. Okay, तो plus लिखेंगे या minus लिखेंगे, but not both. But the question is, the next obvious question is, how do we decide whether it's plus or minus? So let's write that also, that the plus or minus is decided by looking at the domain of f of x. Okay, it's decided by looking at the domain of f of x. Okay, now, here is a logical question. Okay, here's a logical question that I want you guys to pay attention to. I will give you guys a standard rule, and I will give you guys a plan B as well. Okay. So if the domain of f of x is greater than or equal to 3, okay, if the domain of f of x is greater than or equal to 3, then is it correct that the range of f inverse of x will also be greater than or equal to 3? Listen to what I'm saying. If the domain of f of x is greater than or equal to 3, then that means the range of the inverse function will also be greater than or equal to 3. Okay, I hope nobody disagrees. If you disagree, let me know now so we can fix this before we do anything else. Okay, great. So that means if the domain is, all right, I'll explain. So notice domain of f of x becomes the range of f inverse of x. Domain of f of x becomes the range of f inverse of x. So if this is the domain of f of x, okay, if this is the domain of f of x, then that means this should be the range of f inverse of x as well. Correct? If this is the domain of f of x, that means it should be the range of f inverse of x as well. Okay. Now, अब मुझे ये बताएं, should I take plus? And in that case, will the range be greater than or equal to 3 of the inverse function? Or do you think will it be greater than or equal to 3 with the minus sign? Think about it. Should I take plus or minus so that the overall range is greater than or equal to 3? Acha Hussein, that's a different scenario. We'll talk about that later. First, let's focus on what we're doing. Plus, definitely plus. क्यों? क्योंकि हमें चाहिए इसकी range to be greater than or equal to 3. Now we know it's 3 plus minus. Should you add something to 3 in order to make sure that all the values are greater than or equal to 3, or should you subtract something? Definitely you should add something. So that means the answer to part A, where we had to find out the inverse function, now we have already found out the inverse function. We were just confused about the sign. So it would be 3 plus square root of x plus 4. Why? Because according to, if we use this sign, the range of the inverse function is in fact greater than or equal to 3. Okay, I repeat from the beginning. And I'll give you guys a plan B as well, okay? As in, how can you decide whether to go with plus or minus? So since the domain of f of x is greater than or equal to 3, the range of the inverse function should also be greater than or equal to 3. But which sign will give us the desired range? It's the plus sign. Why? Because when you add something to 3, then the overall values will be greater. What about part B, where the range of the inverse function will be lesser than or equal to 3? Why is that? Because the domain was x is lesser than or equal to 3. That means the range of the inverse function must also be lesser than or equal to 3. So which sign should I pick here so that the range is lesser than or equal to 3? And the answer is minus. Everything remains the same. The only difference is that the sign that we pick will be minus. Okay, so I'll repeat, and I'll give you guys another option also. Okay, I'll give you guys another option to figure it out, where you know you won't have to do this every single time. So here's the step-by-step procedure. Look at the domain of f of x. That is going to be the range of f inverse of x. Then decide whether it's the plus sign, which will give values according to that range, or if it's the minus sign. So here the domain was greater than or equal to 3. That means the range of the inverse function will also be greater than or equal to 3. And here it's the positive sign, which will give us the desired range. Here the domain was lesser than or equal to 3 of f of x, which means the range of the inverse function will also be lesser than or equal to 3. Then pick the desired sign, which will give you your answer, which in this case is minus. Okay, now here's a plan B. ठीक है, ये आप लोगों के लिए एक plan B है. Plan B, as in how to decide the plus and minus sign. So here's f of x, which is x minus 3, the whole thing square minus 4, and x is greater than or equal to 3. Now give me any value which is greater than 3. Any value. 7. Okay, so let's take 7. So f of 7, let's see what's that equal to. 7 minus 3 is 4, square of which is 16. 16 minus 4 is 12. Sorry, 7 minus 4 is 3, square of which is 9. 9 minus 4 is 5. So that means f of 7 is equals to 5, correct? So we picked a value as per the domain. Sana suggested 7. 7 minus 4 is 3. 3 square is 9. 9 minus 4 is 5. Now, is it safe to say that f inverse of 5 will be equal to 7? Can I say that? Can I say f inverse of 5 will be... Oh yeah, it's 7 minus 3. So sorry. 7 minus 3, so that means I'm pehle sahi kara, I don't know why it turned into 4. 7 minus 3 is 4, square of which is 16. 16 minus 4 is 12. Okay, thank you. Now, can I say the following? That f inverse of 12 is equals to 7. Can I say that? If you plug in 7 in f of x, you get 12, which means if you plug in 12 in the inverse function, you should get 7. Correct? Okay, now let's do that. So here is, this may be a little bit lengthy, but you will be far more confident if you do it like this. So the inverse function was 3 plus minus square root of x plus 4. Okay, ये था ना हमारा inverse function. So now if in this inverse function, if I plug in 12, and you can do this directly in your calculator also. Reason why I'm writing it down is to explain, but you can do this directly in your calculator as well. So it's going to be 12 plus 4. Now remember, what do we want? We want it to be equal to 7. Now 12 plus 4 is 16. Should I take the positive square root of 16 and then add 3 for it to be equal to 7? Or should I take the negative square root of 16 and then add 3 for it to be equal to 7? The positive square root. That's correct. Because if I take the positive square root, then what happens? We get basically 7. So that means we will take the positive square root of 16. And in that case, it's equal to 7. Okay, so the final answer will be, when we're writing down the inverse function, it's going to be 3 plus square root of x plus 4. Now, let's apply this to part B also. Everything's the same, except that the domain of part B is slightly different. It's lesser than or equal to 3. Now, give me any value which is lesser than or equal to 3. Less than 3, ideally. 2. Okay, let's take 2. And this works with any value. As long as it's in the domain, it's going to work with any value. So 2 minus 3, which is minus 1, square of which is 1. 1 minus 4 is minus 3. Okay. So now this means that f of minus 3 should be equal to 2. F inverse of minus 3, sorry, should be equal to 2. Okay. So here's the inverse function. Let's copy paste this. Let's plug in minus 3 in the inverse function. So that means 3 plus minus 3. Sorry, minus 3 plus 4. Now tell me, minus 3 plus 4 is 1. Should I take the positive square root of 1 or the negative square root of 1 if I want the end result to be equal to 2? Positive square root line, negative square root line. If I take the positive square root, that's going to be 3 plus 1. Positive square root or negative? Negative square root, yes. 3 plus 1 equals to 4. That's not going to help. That means we should take the negative square root, because if you take the negative square root, you get the desired result. So that means the final answer, f inverse of x, will be equal to 3 minus square root of x plus 4. Okay, that is the correct answer. So I hope it's clear. I hope you guys understand the concept. The reason, let me tell you something. The reason why, I'm sure you guys must have heard people complain about how difficult functions is, and they just don't understand. Sir, it is in, oh yeah, positive, sorry. Thank you. So I'm sure you've heard a lot of people complain about functions, it's difficult, domain range ke questions nahi ho rahe. That's because people don't give the due importance to domain range questions. Okay, due importance to the method, the method basically that we need to apply in order to be able to solve questions like these. हम casually करते हैं, अक्सर students काफी casually कर रहे होते हैं domain range के questions को. They don't take them seriously, but you're supposed to take them seriously. As you can see, they are the kind of questions that require effort. So put in the due effort and guaranteed you'll get the correct answer. And also make sure that you understand the concept. रट्टे नहीं लगाएं. Make sure you understand the concept and make sure that you have multiple ways of solving the question. If you can do that, then I can guarantee that you will always get it right, inshallah. Anyway, so now we're going to do some past paper questions. So is it easy to get good marks in Ad Maths? It's not easy to get good marks in Ad Maths. It requires a lot of effort. But the good thing about Ad Maths is that majority of the people who take Ad Maths are the ones who naturally have an inclination towards it. So while it's not easy, but people reach a point where they start enjoying how challenging and how difficult it is. Okay, so if you're not finding it easy, that's fine. But if you're finding it fun, then that's a good state to be in. If you're finding it easy, that's even better. That means you've understood everything, you've gotten a good grip at it. But if you're not finding it easy, but you're finding it fun, you're enjoying it, that's also a good state to be in. I got good in maths. Yeah, Lord, that's true. If you do maths, if you do add maths, your math naturally gets better, no doubt. Okay, so here's a question. It's a past paper question. How many more days? Most likely, inshallah, Friday तक हमारा functions खत्म हो जाना चाहिए. Because अब हमारा 2 classes में हो जाएगा. We're left with exponential and log. Okay, so we're gonna have a separate class for that, inshallah, and then we are left with absolute, yeah, modulus functions, and then we're done. Anyway, so let's solve this question. We have around 15 minutes. Let's make the most of it. So we can solve this question by comparison. We can solve this question by the method that we use in math. Let's use the method that we use in math. I said earlier that I will do an example where the coefficient of x squared is not 1. Yes, Shumaim, it is possible to take inverse of an exponential function. How do you solve exponential equations? Batao mujhe. When you can't make bases the same, then how do you solve? That's correct. You take ln. Good job. ln, LG. Basically, it's when it's e, it's ln. When it's any other number, any other constant, you take lg. So that's how you take the inverse. Okay, now we've had a bit of a problem. We don't have the coefficient of x squared as 1, so that's not a problem. We're going to take 2 common. So if we take 2 common, that's going to be x squared minus 4x. Leave a bit of space and then close the bracket. And then you have plus 5. So what you're going to do is you're going to add something. So you're going to add the square of 2. And you're also going to subtract the square of 2. Okay. So this part of the expression compresses and becomes x minus 2, the whole thing square. Okay, this comes as it is, minus 4. Don't forget that there is a 2 outside, which you have to multiply, and plus 5 as it is. Okay, if you find this a little tricky, like I said, remind me in the group. I'll share a video where you guys can learn this method. So this becomes x minus 2, the whole thing square, minus 8 plus 5, which means the final answer will be x minus 2, the whole thing square, minus 3. Okay, so that's the answer to the first part. Now, part 2. Hence or otherwise, write a suitable domain for f so that f inverse exists. You'll find questions like these very common. They have a standard answer to, there's a standard way to answer questions like these. See if you guys can answer them. What should be the domain of the function above so that inverse exists? And let me tell you, there is more than one answer to it. Think about it.
Sir, can I tell?
Yeah, go ahead.
Sir, x is greater than or equal to 2 or smaller than or
That's
equal
correct.
to, because
That is correct.
because 2 is the x coordinate of the turning point.
Good job. So this function is such that it's turning at 2 comma negative 3. Okay. It's turning at 2 comma negative 3. Now we know that by default, it's a many to one function, which is fine. But if you want to make sure that the inverse exists, then you have to change the domain. Now you can change the domain to x is greater than or equal to 2. Now notice the question says write down a suitable domain. So that means there could be many suitable domains and you just have to write down one. Or it could be x is lesser than or equal to 2. Why are these suitable domains? Because these domains make the function a one-to-one function. Okay, so they make the function a one-to-one function. All right, so I hope it's clear. Now, let's do part B, part 1. The functions, any questions as far as part 1 and part 2 are concerned? Please let me know now. Okay, so I'm judging by the silence, no questions. The function g and h are defined respectively by so-and-so. Write down the range of g. So how will I find out the range of g? It's a quadratic function. Remember, your safest bet to finding the range of a quadratic function is by making a rough sketch. Now, what kind of a curve are we looking at? We're looking at a minimum curve. What do you think will be the coordinates of this curve? Of this quadratic curve? Coordinates of the turning point, sorry. What do you think will be the coordinates of this turning point, of the turning point of this quadratic curve? Think about it. 0, 4. Very good. Why? Because technically it's as good as x minus 0, the whole thing square plus 4. Okay, don't think that you have to change it into completing square form. It's already in completed square form. So 0, 4 means something like this. But here's the thing. The domain that we're given is x is greater than or equal to 0. That means we're only looking at this part of the curve. So what do you think will be the range of this function? Anyone who can answer that?
Y is
What?
greater than 4.
That is correct. Greater than or equal to 4. Okay. Greater than or equal to 4. Okay. So we convert, why did we subtract 0? Just to write it in completing square form. Okay, I was just trying to prove that this technically is already in completed square form. Why? Because we can always write it as x minus 0, the whole thing square plus 4. Okay. So we convert a many-to-one function into one-to-one function to find its inverse. Yes, that's what you do. You convert a many-to-one function to a one-to-one function so that its inverse exists. Okay, now what about the range of H inverse? That's a no-brainer. Think about it. What do you think will be the range of H inverse? Do I really have to find out the inverse function to determine its range? What will be equal to the range of H inverse of X? The domain. Very good, Moise. It's going to be H of X greater than or equal to 0. Why? Because that's what the domain of H of X is. ठीक है, मैं फिर बता रहा हूँ. Don't think functions. If you've understood everything that we have done, that's not an achievement really. That's not an achievement on my part, not an achievement on your part. But the achievement would be if you're able to retain everything that we have done in today's class, and apply it effectively and be able to solve questions. If you can do that, then that's an achievement for all of us. But just understanding it is not good enough. Okay. And in order to retain it, make sure that you go over the notes again and again till everything makes perfect sense to you. Okay. So I have another question which I'd like you guys to solve here. I said, okay, did you make a sketch? Did you make a sketch? Yes or no? If you didn't make a sketch, then I can't guarantee whether you'll get it right or not. So we're looking at a quadratic curve which is turning at -1, 2. ठीक है, क्या देख रहे हैं हम एक quadratic curve देख रहे हैं which is turning at -1, 2. Even if it's a 1-mark question, please make sure that you make a sketch. Now, since we're only looking at x is greater than or equal to -1, that means we're only looking at this part. Yes, 51 is the correct answer. So if you're looking at this part, what do you think will be the range of f of x greater than or equal to 2? ठीक है, sketch बनाने का मतलब ये नहीं है that you take out your scale and your pencil and आप उसको sharp करें and proper measure करके बनाएं. That's not what I mean by making a sketch. Just get the turning point right, draw the curve. That's it. Part 2 is 51. Good job, fellas. Now find an inverse. Remember to pick the right sign for inverse. Part 2, Abira, we have solved part 2, by the way. F square of 1 में मैंने आप लोगों को बताया था that you can do f of 1 and then whatever you get, you plug that back into the function. Okay. Now for part 3, remember you have to pick a sign. The sign that you're going to pick, Mubin, your answer, देखो, for those of you who are giving it to me with the plus minus sign, that's incorrect. And remember, when you've made, you found inverse, make sure to replace y with x. So the correct answer would be x plus 2 inside the positive square root. Okay, so the square root will be positive -1. Okay, why would it be positive? Because if you want the range of this to be greater than or equal to -1, you will have to make sure that you're always adding something to -1. Okay, now quickly do. Sorry, it's x minus 2. Sorry, it's x minus 2. Thank you, Saad, for pointing that out. Go ahead. Do the rest of the parts. And you guys will find a worksheet maybe by tonight latest. And there was an error in the last worksheet, which I have fixed. You guys can check. We have sine x, which is equal to 0.5. What happens when you, sine is a function, right? What happens when you take sine across the equals to sign? It becomes sine inverse. Okay, so we can save some time over here because we've already found f inverse. So if I take f across the equals to sign, that means it becomes f inverse of 38. Okay, now what you can do is in the inverse function, you can simply plug in 38. So that's going to be 38 minus 2 inside the square root, since that's what the inverse function was, minus 1. And this is what g of x will be equal to. Okay, so g of x is equals to 38 minus 2, that's 36, square root of which is 6, 6 minus 1 is 5. So that means now what you're solving is basically g of x equals to 5. Okay, which means 20 over x plus 1 equals to 5. Now let's solve this. It's going to be 20 is equals to 5x plus 5, which means 5x is equals to 15, which means x equals to 3. So this way, you won't have to form the composite function, although you can do it. That's perfectly all right. But this way, you'll end up saving some time for yourself. Okay, so I'll repeat. If let's say you have f of x, which is equal to 3, that means x can be written as f inverse of 3, and vice versa. If let's say you have f inverse of 5, which is equal to a, that means 5 can be written as f of a. Okay, so remember this rule, another note you can say, which you guys should add to the list.